Somewhere in a stack of James Webb Space Telescope data, at a wavelength almost nobody had ever bothered to look at closely before, a group of scientists found something that, according to every catalog of known chemistry humanity has ever built, should not exist. Not a new planet, not a new moon, a signature, a very specific, very narrow dip in the light coming back from two of the strangest worlds in our solar system, sitting at a wavelength that matches nothing on record. No molecule we know of, no compound cataloged in any laboratory on Earth. And here's the detail that turned this from a curiosity into a genuine puzzle. It is not showing up on one distant world. It is showing up on two completely different ones. Worlds that share almost nothing in common, 4 billion miles apart from each other, in nature, if not in distance. And nobody currently knows what it is. Let's start with where this actually came from, because the setup matters. The James Webb Space Telescope was never built specifically to stare at Pluto. Its real headline missions are galaxies at the edge of the observable universe, atmospheres of planets orbiting other stars, the earliest light in the cosmos. But because Webb's instruments are so extraordinarily sensitive, capable of picking apart light into wavelengths so fine that older telescopes simply could not resolve them, scientists have also been quietly pointing it at targets much closer to home, places we thought we already understood. And in a study using this data, researchers went looking at a very specific narrow sliver of the infrared spectrum, a region that had barely been explored in previous observations, focused on two targets: Pluto, the small frozen world at the outer edge of our solar system, and Titan, Saturn's largest moon. To understand why finding the same unexplained signature on both of these worlds is strange, you first need to understand how different they actually are from each other. Titan is enormous for a moon. It is larger than the planet Mercury. It is the only place in the entire solar system other than Earth, known to have rivers, lakes, and seas sitting right there on its surface, though what flows in them is liquid methane and ethane instead of water, at temperatures cold enough to freeze that water solid instantly. Titan orbits Saturn, sitting relatively close to the Sun compared to what comes next. Pluto, by contrast, is roughly half the size of Titan and sits about 4 times farther from the Sun than Saturn does. It's a small, frozen, quiet world with no liquid surface features at all, a dwarf planet drifting through the coldest, dimmest region of our solar system, illuminated by a sun that from that distance looks like nothing more than an unusually bright star. 2 worlds, different sizes, different locations, different surface conditions, different histories. About the only thing they genuinely share is an atmosphere built primarily from methane and nitrogen. And yet, when researchers examined the James Webb data from both of these worlds, they found the exact same thing in both places, a very specific absorption line, centered at a wavelength of about 5.11 micrometers. In plain terms, that means something on the surface of both Pluto and Titan is soaking up light at that exact wavelength, leaving a fingerprint, a dip, a gap in the spectrum that reflects back to Webb's instruments. And when the researchers went looking through the existing scientific literature, cross-referencing every catalog of known chemical compounds and their absorption signatures that they could find, they came up empty. As they put it in their own paper, they did not find any previously documented band that corresponds to the location of this observed absorption in either world. Stop and actually sit with what that means. Every molecule in the universe, every element, every compound, has a specific signature written into the way it interacts with light. That's the entire basis of how we identify what things are made of, from millions or billions of miles away, without ever physically touching them. Oxygen absorbs at a specific known wavelength. Carbon dioxide absorbs at another. Water, methane, ammonia, all of them have their own individual fingerprints cataloged and confirmed through decades of laboratory work here on Earth and observations across the solar system. When scientists point an instrument like Webb at a distant world and see an absorption line at a wavelength that matches something already known, they can say with confidence exactly what they're looking at. What happened here is different. The researchers found a real, measurable physical signal present on 2 separate worlds, and when they checked it against everything humanity has ever cataloged, nothing matched. Whatever is doing this absorbing has either never been identified before, or has never been documented producing a signature at exactly this wavelength under these conditions. And it gets stranger the deeper you look at the details. On Pluto, this unexplained absorption line is roughly 3 times wider, 3 times thicker than the same signal on Titan. In spectroscopy, a wider absorption line at the same wavelength generally suggests a greater abundance of whatever is doing the absorbing. Which means, whatever this substance actually is, there appears to be considerably more of it sitting on Pluto's surface than on Titan's. And on Titan specifically, the researchers found something even more peculiar. The signal isn't spread evenly across the moon at all. It shows up more strongly on Titan's trailing hemisphere, the side of the moon that faces backward relative to the direction it travels in its orbit around Saturn, than on its leading hemisphere, the side facing forward. That kind of lopsided distribution is not random. It's the kind of pattern that, in other contexts, has been linked to things like radiation exposure, particle bombardment, or chemical processes that depend on which side of a moon is more exposed to its environment as it moves through space. Something about the physical process, creating or depositing this substance, treats one side of Titan differently than the other. So what could it actually be? The scientists behind this discovery didn't just throw up their hands, they proposed a few candidates worth testing. One possibility is benzene, a ring-shaped hydrocarbon molecule that's already known to exist in trace amounts in some outer solar system environments, potentially combined with some additional unknown compound that shifts its usual signature. Another possibility involves forms of acetylene, or a compound called ketene, frozen into ice at these extraordinarily low temperatures, which behaves differently than it would as a gas, and could theoretically produce an absorption signature unlike anything previously logged. But, and this is important to say plainly, none of these candidates have been confirmed. As of when this research was released, the team explicitly states that considerably more work is needed before anyone can say with certainty which, if any, of these compounds is actually responsible. There's also a detail worth being straightforward about, because getting this exactly right matters more than making it sound bigger than it is. This finding was first shared in mid-June of 2026 as a preprint, meaning the paper had been made public for the scientific community to see and scrutinize, but had not yet completed the full formal peer review process that turns a research paper into an accepted, verified scientific finding. That doesn't mean the data is wrong. The James Webb measurements themselves are real, and the absorption signal genuinely does not match anything currently cataloged. But in science, the space between an intriguing raw result and a confirmed discovery is exactly where the hardest, most careful work happens. Other researchers now get to examine the same data, propose their own explanations, and either confirm or challenge what this first team has found. That process is still ongoing. Now here's the part that makes this feel less like a footnote and more like the opening of something much bigger. If this really is an unidentified molecule, one that exists in meaningful quantities on the surface of Pluto and in a different concentration and distribution pattern on the surface of Titan, then scientists are looking at direct physical evidence of a chemical process happening in our own solar system that nobody has previously documented or explained, not a hypothetical, not a model prediction, an actual measurable signal sitting in real data from real telescope observations that doesn't fit into any existing box. And the reason this specific pair of worlds matters so much is that Pluto and Titan represent two of the most chemically active, most scientifically compelling surfaces in the entire outer solar system, precisely because they are cold enough and far enough from the sun's destructive ultraviolet radiation that complex organic chemistry can survive there instead of being broken apart. Titan's thick atmosphere is loaded with the kind of hydrocarbon chemistry that some scientists consider a distant analog for the conditions that may have existed on early Earth before life ever began here. Pluto, once dismissed as a dead ball of ice, was completely upended in scientific understanding after NASA's New Horizons spacecraft flew past it in 2015 and revealed a world with towering ice mountains, vast frozen plains, and a genuinely active evolving surface, nothing like the frozen, static rock scientists had expected. Since then, James Webb has kept finding more reasons to take Pluto seriously as a complex, dynamic world in its own right, including recent findings about a high-altitude atmospheric haze that appears to actively regulate Pluto's climate in ways strikingly similar to processes seen on Titan. Given that history, finding yet another shared, unexplained chemical signature between these two worlds isn't just a curiosity, it's a pattern. And patterns, in science, tend to point towards something real waiting to be understood. So what happens next? Right now, the honest answer is that we wait, and we keep looking. There is no laboratory on Earth currently confirmed to have reproduced this exact signature under matching conditions, and no instrument currently in operation that can get closer to either Pluto or Titan than James Webb already has from Earth orbit. But there is one mission already on the calendar that could eventually settle this. NASA's Dragonfly mission, a nuclear-powered rotorcraft lander designed to actually fly through Titan's atmosphere and touch down on its surface, is currently planned to launch no earlier than 2028, with an anticipated arrival at Titan in the mid-2030s. Dragonfly is equipped with its own onboard spectrometer, an instrument built specifically to identify the chemical composition of whatever it finds on Titan's surface directly, up close, instead of interpreting faint light signatures from across the solar system. If this mystery substance really is sitting there in meaningful quantities, Dragonfly may be the mission that finally puts a name to it. And if it does, whatever answer comes back from Titan could also help explain what's sitting on Pluto too, given how similar the underlying signal appears to be. Until then, this stays exactly what it currently is. A measurable physical signal sitting in real telescope data at a wavelength that matches nothing currently known to science, appearing on two of the strangest and most different worlds in our solar system in different amounts, distributed in a pattern that isn't random. That is not nothing. In the entire history of planetary science, unexplained data like this has, more than once, turned out to be the first sign of something nobody had thought to look for. The absorption lines of ozone in Earth's own atmosphere were once just as unexplained, before scientists worked out exactly what was creating them and how much it mattered for life on this planet. The unusual composition readings from Titan's atmosphere itself once looked like anomalies before an entire body of research grew up around understanding its complex hydrocarbon chemistry. Right now, this signal from Pluto and Titan sits in that same uncertain, unresolved space. Real, documented, unexplained. And waiting for someone somewhere to figure out exactly what it is. Here's what makes this such a remarkable moment to actually be paying attention to. James Webb was designed and built to look back toward the very beginning of the universe, toward light that has been traveling for over 13 billion years just to reach its mirrors. And in the middle of doing exactly that, in the middle of rewriting our understanding of galaxies that existed almost since the beginning of time itself, it turned its incredibly sensitive instruments toward two small, cold worlds practically in our own backyard, and found something we cannot yet explain, sitting right here, inside our own solar system, hiding in plain sight the entire time, simply because nobody had ever looked at exactly that wavelength closely enough before. Whatever this substance turns out to be, whether it's a known compound behaving in a way nobody expected, or something genuinely new to cataloged chemistry, one thing is already certain. There is real physical chemistry happening on the surfaces of these two distant worlds that our current scientific understanding cannot yet account for. And that gap, the space between the data we have and the explanation we don't, is exactly where the next real discovery in planetary science is going to come from. Because the truth is, this is what real scientific discovery almost always looks like in the moment it's actually happening. Not a dramatic headline with all the answers already worked out. A strange signal in the data, a question nobody can currently answer. A gap between what we've cataloged and what's actually out there. And a handful of scientists, sitting with results they cannot fully explain yet, choosing to publish the mystery honestly instead of waiting until it's neatly solved. Somewhere between Pluto and Titan, there's a molecule with no name. And for now, that unanswered question is exactly what makes this one of the most genuinely interesting results to come out of the James Webb Space Telescope all year. If stories like this, the ones sitting right at the edge of what we actually know, are what you come here for, stay close. Because there is more just like it, still waiting to be uncovered.